Science of sleep. How sleep works. The precise reason for why we sleep is still one of the most lasting and intriguing mysteries in the field of health science, even after decades of research into the topic. In order to get to the bottom of this topic, experts have been researching how sleep operates and what happens to our bodies when we don't get enough of it. Studies have shown that sleep is an exceedingly complicated process that influences almost all of the body's different systems. Multiple regions of the brain are responsible for the production of the hormones and chemicals that control sleep and wakefulness. These regions are also engaged in the process. The current collection of research provides light on the mechanisms of what happens in the brain and the body during sleep. This is despite the fact that there is still a great deal to be discovered about the complexities of how sleep actually works. This knowledge elucidates the myriad ways in which one's physical, emotional, and mental health are intertwined with sleep, and it also offers suggestions for how individuals can improve their quality of slumber. What happens when you sleep? As quickly as 1 minute after dozing off, noticeable shifts can be observed occurring in both the body and the brain. The temperature of the body reduces, the activity of the brain slows down, and both the pulse rate and breathing rate fall down as well. It shouldn't come as a surprise that the body's energy expenditure drops while it's sleeping. However, it is essential to be aware that the processes that take place during sleep are ever-changing. During the course of a single night, you go through a number of different sleep cycles, each of which can last anywhere from 70 to 120 minutes and is made up of a number of distinct stages of sleep. The stages of sleep are extremely important to the functioning of sleep overall. What are the sleep stages? There are 4 distinct stages of sleep, each of which can be grouped into one of 2 types. The first 3 stages are classified as non-REM, non-rapid eye movement, sleep. REM stands for rapid eye movement. REM sleep is the 4th stage of the sleep cycle. In stage 1, you have just drifted off to sleep and have begun the transition to stage 2, which involves a further slowdown of activity in both the brain and the body. During these earlier stages of the sleep cycle, it is significantly simpler to rouse someone from sleep. The most profound level of non-REM sleep is known as stage 3. During this stage, your muscles and body relax even further, and your brainwaves reveal a definite pattern of slowed activity that is clearly distinguishable from the activity of an awake brain. It is widely held that restorative sleep plays a significant part in not only the physical recovery of an individual but also in their ability to think clearly and remember information. Only stage 4 of sleep is considered to be REM sleep. During this moment, the activity in the brain picks up significantly, and the majority of the body experiences a temporary paralysis, with the exception of the muscles that control breathing and the eyes. Even though dreaming can take place throughout any stage of sleep, REM sleep is when the dreaming is at its most vivid and active. It is considered that the REM stage of sleep is necessary for the brain, as it enables important activities such as learning and remembering. It is usual to spend a greater percentage of time in rapid eye movement, REM, sleep as the night goes on, with the majority of REM sleep occurring in the second half of the night. The stages and cycles that occurred during a person's sleep are referred to together as their sleep architecture. The scientists feel that each stage plays a function in a healthy sleep architecture that creates quality sleep, despite the fact that deep sleep and REM sleep involve more profound changes in activity levels than the other stages do. How does the body regulate sleep? Both the sleep-wake homeostasis and the circadian alerting system play an important role in the process of regulating sleep in the body. Sleep-wake homeostasis. This scientific word reflects something that the vast majority of us understand intuitively based on our own experiences. The more awake time you spend, the greater the need you have to sleep. This occurs as a result of the homeostatic sleep drive, a self-regulating system within the body in which the pressure to sleep increases depending on how long a person has been awake. After a stretch of not getting enough sleep, you may find that you sleep for longer periods of time or that you sleep more deeply. The circadian timing of the alarm system. Circadian rhythms are a component of your body's internal biological clock. These rhythms typically persist for around 24 hours and play an important part in a variety of biological activities, including sleep. The most significant factor in determining circadian rhythms is exposure to light, which promotes wakefulness during the day and sleepiness during the night. Your biological clock, the time of day, the amount of light exposure you've had, and the amount of time you've been awake all have a role in how much your body feels the need to sleep. These two factors also play a direct role. In addition, the balance of sleep and wakefulness, as well as the circadian alerting system, can be disrupted by a wide variety of extraneous circumstances. For instance, your body's regular method for regulating sleep can be thrown off kilter if you're stressed out or hungry. Consuming caffeine or being exposed to the light from electronic gadgets are two more instances of how a person's choices and behavior can influence the fundamental processes that control how much and how well they sleep. The hypothalamus, the thalamus, the pineal gland, the basal forebrain, the midbrain, the brainstem, the amygdala, and the cerebral cortex are the areas of the brain that are responsible for managing these complex processes. The biological complexity of sleep is further illustrated by the fact that awake and sleep include participation from a large number of different areas of the brain, including the stages of sleep. Which hormones and chemicals are responsible for sleep regulation? Both the sleep-wake homeostasis mechanism and the circadian alerting system entail a large number of different substances and hormones in their operation. Alterations are made to thousands of neurons in the brain during the transition between awake and sleep, as well as to a complex signaling system that is responsible for producing particular responses in the body. Researchers have found several compounds that appear to be crucial gears in the machinery of sleep, but there is still a lot that is still unclear about the intricate mechanisms that control sleep. Despite this, there are some molecules that have been discovered. It is believed that the chemical known as adenosine plays a significant part in the regulation of the sleep-wake cycle. When we are awake, adenosine accumulates in our bodies, and this appears to enhance the sleep pressure. On the other hand, caffeine inhibits the activity of adenosine, which may help to explain, at least in part, how it stimulates wakefulness. Chemicals known as neurotransmitters are responsible for transmitting messages across the nervous system to either activate or deactivate certain cells. GABA, acetylcholine, orexin, and serotonin are some examples of neurotransmitters that are involved in the process of encouraging wakefulness or sleep. In addition, hormones play a significant part in both the signaling and the regulation of sleep and wake states. Melatonin is one of the most well-known hormones associated with sleep. It is created naturally in the body when there is less exposure to light, and it works to induce sleep. In addition to these hormones, adrenaline, cortisol, and norepinephrine all play a significant role in the regulation of sleep. Additionally, sleep can have an effect on the synthesis of essential hormones such as growth hormone, as well as leptin and ghrelin, which control appetite and may have an effect on sleep-wake homeostasis and circadian rhythms. These hormones include: because the activity of these chemicals and hormones can vary from person to person according on their heredity, it is possible that certain sleep disorders can run in families. The chemical and hormonal signaling that is important for sleep may also be influenced by environmental factors and choices in lifestyle. Why is it necessary to get enough sleep? Numerous pieces of evidence point to sleep having an important role in our biological processes, despite the fact that not even the most knowledgeable scientists can agree on an explanation for why we do it. Even while it makes animals more susceptible to danger and diverts their attention away from activities such as eating and reproducing, the fact that practically all animal species engage in sleep despite these drawbacks provides compelling evidence that it is a necessary component of health. It would appear that getting adequate amounts of sleep is crucial to the development of both the body and the mind in human infants, children, and young adults. In adults, a lack of sleep has been linked to a wide variety of negative health consequences, some of which include cardiovascular disease, a weakened immune system, a higher risk of obesity and type 2 diabetes 13, impaired thinking and memory, and mental health problems such as depression and anxiety. These various negative effects of not getting enough sleep lend credence to the idea that sleep serves more than one biological function. Rather, it is, by virtue of its complexity, an essential factor in the health and efficiency of almost all of the body's systems. Thank you for being with us. Don't forget to subscribe.